decades-long journey of exploring the universe, humanity has achieved great accomplishments, from the first moment of capturing an image of a black hole to the discovery of thousands of worlds beyond our solar system. But never before have I felt we were so close to humanity's oldest question as now. Are we truly alone in the vast universe? Recently, the James Webb Space Telescope, the most sophisticated observation machine ever built by humans, detected a signal from the planet K2-18b. Chemical compounds such as dimethyl sulfide, abbreviated as DMS, and dimethyl disulfide, DMDS, both are known as byproducts of life on Earth. The planet, located over 120 light-years from Earth, shows clear and strong signs that life may be present there. So what is happening on K2-18b, and could this discovery be the first clue leading us to another civilization beyond Earth? Prepare yourselves, because what you are about to discover today may forever change how you view extraterrestrial life. Welcome to the video on the clearest signs of life detected on K2-18b. K2-18b, also known as EPIC 2019-12552b, is an exoplanet orbiting a faint red dwarf star K2-18, located about 124 light-years from Earth. The planet is about 2.6 times the size of Earth and about 8.6 times more massive, so you could call it a super-Earth. K2-18b was first discovered in 2015 by the Kepler Space Telescope, but at that time, it didn't attract much attention. It seemed just one of countless strange planets outside our solar system. However, everything changed in 2017 when more precise data from the Spitzer telescope showed that K2-18b lies in the habitable zone of its host star, meaning it has the ideal temperature conditions for liquid water to exist. The planet immediately became a favorite among researchers, with many of our most powerful astronomical observatories turning their gaze toward this special exoplanet. The planet is about 0.16 astronomical units, AU, from its host star, equivalent to 21.38 million kilometers, only half the distance of Mercury from the Sun. And because it orbits so close to its host star, it takes only 33 Earth days to complete one orbit, a short enough time for many observers to notice and focus on tracking its orbit. The real excitement came in 2019 when the Hubble and Spitzer space telescopes simultaneously detected traces of water vapor in K2-18b's atmosphere, increasing the fascination with this system even more. In 2023, the James Webb Space Telescope began pointing its sophisticated lens toward K2-18b and detected carbon and methane in its atmosphere. This is the first time carbon-based molecules have been detected on a planet in the habitable zone. Thus, with all that is known about K2-18b, it is a promising planet for life. K2-18b lies in the habitable zone of its host star. Its surface may be covered by liquid oceans, and its atmosphere is rich in hydrogen. In 2021, a new type of highly promising planet was proposed, called hycean planets, and K2-18b is a prime example among them. In the boldest hypotheses, hycean is a place where deep oceans cover the entire surface. And above is a hydrogen-rich atmosphere, a strange combination that could create perfect conditions for life to sprout and develop. To verify this promising hypothesis, scientists continued using the James Webb Space Telescope to observe K2-18b more closely. The goal was to find undeniable signs of life, and the results truly exceeded all expectations. In the latest analysis data, James Webb detected the presence of two rare compounds in K2-18b's atmosphere, which are dimethyl sulfide and dimethyl disulfide. Both are chemical signatures that we only know as byproducts of life on Earth. On Earth, dimethyl sulfide or DMS is one of the most characteristic biosignatures. Interestingly, it doesn't come from large organisms or complex processes but originates from an invisible world within the ocean. Hidden deep beneath the seemingly calm waters are trillions of plankton, organisms smaller than dust particles, floating in the vast ocean. They may be small but hold a vital role in the ecosystem and even influence the global climate. During their life, plankton secrete a special compound called DMSP as a way to adapt to the environment, regulate pressure, or protect themselves from sunlight. When they die or are consumed by other organisms, DMSP breaks down and transforms into DMS, a volatile compound. DMS then escapes the sea surface, rises into the air, where it contributes to cloud formation and affects the climate. But most importantly, DMS is a marker that only life can leave behind. The concentrations of DMS and DMDS in K2-18b's atmosphere are much higher than on Earth. On our planet, they are typically less than 1 part per billion by volume. Whereas on K2-18b, they are estimated to be over 10 parts per million by volume, thousands of times stronger than on Earth. Professor Nico Madhusudan from the Cambridge Institute of Astronomy, who led the research, shared. The signal is very clear and strong. Previous theoretical work had predicted that high concentrations of sulfur-containing gases like DMS and DMDS could exist in hycean worlds. Now, we have observed that it matches what was predicted. With all we know about this planet, a hycean world with oceans full of life is the scenario that best fits the data we have. Although the research results are very exciting, the research team remains cautious. He believes that more independent observations are needed before declaring that humans have truly found life on other planets. Especially, it's necessary to check whether those two compounds could be produced by some non-biological method. So if those chemical traces are real, DMS, DMDS, methane, carbon dioxide, along with signs of water vapor. What does that say about K2-18b? What could exist on that distant world? First, let's consider the environmental conditions. K2-18b receives a similar amount of radiation as Earth receives from the Sun. Its temperature ranges from approximately -23 degrees Celsius to 27 degrees Celsius. The habitability of this planet depends on its atmosphere. With a dense atmosphere, high pressure, and temperatures suitable for liquid water to exist, K2-18b could possess a global ocean, a massive water world beneath thick clouds. Any life, if present, would have to adapt to darkness, immense pressure, and scarce energy penetrating the atmosphere. In that context, the most common life form scientists predict is marine microorganisms. Similar to the most ancient organisms that ever appeared on Earth, they could survive in oxygen-deficient environments, utilizing chemical energy from reactions between water and minerals on the ocean floor. Similar to ecosystems around deep-sea hydrothermal vents today. But the hypothesis isn't stopped there. Some astronomers suggest that if conditions remain stable long enough, life on K2-18b could very well evolve into more complex forms. It might even be organisms floating in the upper ocean layer, absorbing faint light, penetrating through thick clouds, similar to how plants use photosynthesis. These organisms could float like jellyfish or exist as biological bags, suspended by light gases in the atmosphere. Nor can we rule out the possibility that if evolutionary conditions are favorable and time is sufficiently long, life on K2-18b could have developed consciousness. An alien, intelligent, and silent ocean civilization, hidden beneath thick clouds, observing the universe from the other side of the chessboard. If the chemical molecules recorded by James Webb are not random, if DMS and DMDS do not come from mindless physical phenomena but from a real, existing life form, breathing and living over 120 light-years from Earth, that would change everything. changing how we view the universe, changing how we see ourselves. Because for centuries, humans have always believed we are the center, the only conscious beings in the vast expanse of the universe. But if K2-18b has life, this means the universe is not as silent as we thought, but rather, it is vibrant, complex, and full of possibilities beyond imagination. It raises deeper questions than any exploration. Is life common in the universe? How many second Earths are hiding in the darkness? And more importantly, are we being observed just as we observe them? Scientifically, if confirmed, this would be the greatest discovery in human history, surpassing even the discovery of fire, the invention of the telescope, or landing on the moon. Because it proves one thing: we are not alone in the universe. However, at a distance of 124 light-years, how could humans possibly go there to verify? This question is truly difficult, as currently, humanity's farthest flying spacecraft is Voyager 1. After a journey of over 47 years, it has only traveled about 25 billion kilometers, equivalent to 23 light-hours. At that speed, the spacecraft would need about 47,000 years of continuous flight to cover 124 light-years. This is certainly an outcome no one desires. But our technology is only at this level. Unless in the future, scientists can build super-advanced spacecraft capable of instantaneous travel, then we might have hope of visiting K2-18b. Although it's very difficult to set foot on K2-18b right now, upon discovering DMS and DMDS, we understand that world could harbor life. We have just taken a long step, not with our feet but with our awareness. Thank you for joining Oddity Odyssey in today's video. If you found this video interesting and thought-provoking, don't forget to like, share, and subscribe to the Oddity Odyssey channel so you don't. See you somewhere among the stars in our next journeys. Warm regards and goodbye.